Welcome back to Range Bible Channel. Today we're going to be looking at Range Engine Python API. To access the API documentation, you visit rangeengine.tech, select API, and then choose the API that matches the Range version you are using. So for now, we're going to be using Range 1.5 API. This is what we see when we open the page. You can use the search bar to search for methods or functions. You can press the download icon to download the current page for offline use. You can use this icon to toggle full screen mode, and also use this icon to switch between dark and light mode. Here I already created a Range project with game objects and a Python component template. Let us attach it to the black cube, because in my case that's my main character. So for us to be able to refer to any of the objects in the current scene, we have to get the scene using a range Python method. Let us go to the API and see how we can do that. In Range, getting the scene is a logic module general function, and it's found under API reference and then Range game engine modules. Click Game Logic and look for a function that speaks of getting the current scene under general functions. If you scroll down, you will find a lot of functions too, which will be needed to create very powerful game logic with Python. And we will look at each and every function in dedicated videos, demonstrating the good methods to use them. After seeing how we get the current scene in the API, we then get back to our script and type exactly what we have, red storing the current scene in a variable called self.scene. So the scene is where our game objects are created and interact with each other. To get the objects, we first get the scene, then get objects from the scene and store them inside a variable called self.objects. And the Python method for that is self.scene.objects. If we print our self.objects variable, we get a list of all the objects in our current scene. Let's go ahead and get all our objects by their individual names, storing them in variables. Let's start by getting the red cube. We type self.red, and that's our variable name, equals to self.objectRed, where red, with capital R, is the actual name of our red cube. Let's go ahead and get the rest of the cubes, storing them in their respective variables. For us to be able to manipulate our game objects' behaviors, we will need to look for methods or functions in the API that are used to do that job. If we go to the API documentation, we will find game objects functions inside the types module because RangeEngine treats a game object as a type. Let's select KXGameObject, and we will find a lot of methods which works to manipulate objects in the right tab. To demonstrate this, let's start by using a method which manipulates GameObject's world scale. If you select it, you will find more information about the method, and in this case, we are being told that world scale determines the scale X, scale Y, and scale Z. You will also see the type of values required, and in this case, it's a Matutils vector type. We apply the word scale by typing our object variable name first, then the method which we want to use to affect the chosen object. Here we wrote self.red.worldscale.y because we want to change only the y scale to be equal to our scale variable. If we play, we will see our red cube changing its y scale. We can also change the scale of all axes by not specifying the coordinate to change using this method, where we put 3 values inside, where the first value represents x-axis, the second value represents y, and the third value represents z-axis. If we play, we will see our yellow cube scale changes. Another thing we can do to the object is applying movement. To find the method to use to apply movement, we go to the API and find movement-related method. And in this case, it's called apply movement. If we click on it, we will find more information about this method, including the required parameters. Let's go ahead and use it by typing our object variable, then .apply movement. And inside, we put our vector type parameter as the API told us. We can create a local speed variable and multiply it by delta time. Speaking of delta time, it's a logic general function which is found under range.logic. Let's apply speed along x-axis only. If we play, our blue cube is now moving along x-axis. We can change our speed value till we get the speed we want. We can also parent objects using Python. We just go to the API and look for a method that speaks of setting or getting parent and read information to know what each method does. So setParent is the one which we want, and it requires the name of the object which we want to parent our object to. We are not going to use the other two parameters because there is no need to use them in our case, but we will get back in a dedicated video to explain what these all does. White is moving because it's a child of a moving blue, so wherever blue goes, white follows. Let us create a timer variable and give it a value of 200. Let's get our text object as well because we want to use it to display our timer value. So if our timer is greater than 0, we want to subtract 1 from it. Then, if our timer is equal to 0, we want to parent our white cube to the blue cube. To display our text property, we create a text property for our text object and set it to be equal to our timer value. We will also fully explain getting properties with Python in a dedicated video. For now, let's focus on reading the API and applying the methods and functions. If we play, our setParent function gets executed as soon as the timer is 0. We can also rotate objects in the scene, and this is the method which does that job. Like how we applied movement, we do the same with rotation using our speed variable as a speed for our green object to rotate along z-axis. If we play, we should see our green object rotating as soon as our timer gets to 0. Now let's talk about manipulating non-mesh objects such as lights. We first get our light objects by their names and store them inside variables. Here we want to manipulate all of the lights. We do so by creating a list which holds all light objects. In the API, we click on KXLightObject to see the methods which works for light objects, and there are many of them. Let's choose the color method so that we can use it to change the color of our lights. The light color type in range is a list which contains red, green, and blue values. Let's type for light in self.lights to iterate through our lights list and manipulate them at ones. Here, let's give our lights a red color. We can change these RGB values till we get the color that we want. Let us change the color according to our timer as well. As you can see, as soon as the timer is 0, our light color changes. Let's go ahead and look for a method which is used to change the energy of our lights. The required value according to this API is a float. So let's go ahead and do that by typing lights.energy equals our float value, and in this case, it's 0.2. If we play, we see the light's strength has been reduced to the specified value. We can increase the light intensity according to our timer as well. So all you do is go to the API, find methods or functions responsible for what you want to do, and go back to your script and apply it according to the API. Thanks for watching, hoping you just learned a very important lesson. In our next series of videos, I'm going to be showing you how to do different stuff using Python components in Range Game Engine in a very detailed way. It will be very wise and helpful to subscribe to this channel and hit the bell icon so that you will not miss all the videos we're going to be uploading from today onwards.